welcome Algebra. This is section 3.8, the last section of chapter 3. And so we're ready for this today with class of 2016, a new and refreshing video. Okay. And today we're going to rewrite equations and formulas. What does it mean if I say, stop taking me so literally? What does that mean? Nick? Yeah, okay, so in baseball, somebody says, run home. So what do? They run to their home where their bedroom is. Yes, that's taking somebody literally. So how else could you say it? What does it mean to take something literally? Hit the books, and so they literally pound on a book, okay, instead of studying. It means to study, right? And Caroline?
If you take the non-literal term of it, you said run home.
It says take the non-literal term. So, but it's never fair to discuss a word using the word in the discussion of the word. And she just used literal. So literal means something like the absolute meaning of the word, I guess. It's like absolute value, right? So when you say home, they're thinking of going to their house. When you say hitting the books, they're thinking of literally hitting it, you know? And so we know what that word means. In algebra, a literal it can mean a variable. Variables are sometimes called literals. So when we deal with a literal equation, what is in it?
A variable.
Or more than one, right? Variable. Equation with letters that have replaced coefficients and constants. And so our most familiar type of literal equations are formulas. Okay, so we're working with equations that do not always have values to substitute into the variables. Okay, so here we have a literal equation. A times x plus b equals c. If I know values for some of these variables, I might substitute them. And when we do, we call this equation a specific equation. Jot it down, or you won't know what that means. A specific equation makes a statement that is true for some situation. So we actually can solve for x in this specific equation, since it is the only variable. We could also solve for x in this literal equation. So what does it mean to solve for x? Mark.
Find value.
Okay, so over here in this specific equation, could we find the actual value of x?
Yes.
Let's do that. So what would you do first to find the value of x? Okay, so you could do that. Then you would? And x equals 1. So we just solved for x in the specific equation. Can we solve for x? No. X equals 1. And we actually placed x all by itself. So when you solve for a variable, you're isolating the variable. So can we take this literal equation and isolate x? Yes, we can. So somebody tell me, what would we do first to isolate x? And others. I want to do it differently because if I distribute a, then I have, it's really trickier. So what's the other thing that Trevor could have done in the very first step here? What could he have done with the 5 rather than distribute everyone? Divide. So let's do that over here. we're going to divide both sides by A. We end up with equals C over A. Now, everyone finish it. Isolate X. Solve for X. Kaylin, tell us, what's the last thing you need to move away from the X? Okay, so how do you move it? Good job. See, you can do that. Subtract it from both sides. I know it's different because there's no letters, but do we have X alone? We did it then. Okay. So how would you write this? Who can say it for us? Audrey. Minus B. Look at that. There it is. You just took a literal equation and is equivalent to and we isolated X. So we are going to solve the literal equation for X, and then we'll use the solution to solve the specific equation. Okay, so we're going to take this literal equation, I'll rewrite it. And solve for X first. And then we're going to do something with the literal equation in a moment. So what will we do first? Solve for X. Now, if you divide by B, let's see what happens. You've got to divide the whole side by B, which means you are, remember, distributing your division, or each term is divided by B, which kind of makes this messy. You end up with A over B minus B over B is what?
1.
1x. 1x equals C over B. Now I have B's on both sides. This is interesting. So rather than doing your undoing of multiplication first, we have said it's probably easier to undo any addition or subtraction first. So, I mean, of course, you can treat both sides of the equation the same and do an infinite number of things to it. But it's probably simpler to undo the addition or subtraction. So who can tell us? Adrian. Subtract A. We have negative X. And then the last step. Okay. And so you end up with 1x equals C minus A. Okay, now to solve the literal equation, we need to identify what is A, what is B, and what is C. So we come up here, and here was A. Is this equation in the same format as the literal equation? Yes. So what is A in our literal equation? I mean, in our specific equation. So A is 12, and B was this, so it's what? Is it negative 5 or is it 5?
5.
Okay, so who says negative 5? Who says 5? It's 5 because we're subtracting 5. See that? And C is
Negative.
negative 3. Okay, so does everyone understand why B is positive 5?
Yep.
Look at it, compare it to the literal equation. We were subtracting what? We're subtracting B, right? Bx. And here we're subtracting 5x. So 5 must be positive. So now that we have these letters and their known values, we can take and substitute them into the literal equation that we have transformed down here. X equals B is negative 3 minus A is 12 and B is 5. So that's negative 5.
So that's not right.
Okay, who can tell us negative 3 minus 12 is?
Negative 15.
Over negative 5 is?
5.
We have 5.
5.
Okay.
Watch like 2
And
5.
no, the answer is 3, not 5. Negative 15 divided by
Okay.
negative 5 is 3. Try this one on your own and come back and check your work with what we found here in the classroom. What What makes it more difficult isolating the x in this equation?
The 11.
I'm not talking about this. We're using the literal equation, Caroline. Right, so the first step will be to do what? Actually, we want to bring all the x's to one side. So which one would you move? Would you move the ax or would you move the bx? Trevor. Right, so let's bring the bx over to the left. So how would we do that? From both sides. So we have ax minus bx equals c. Now here's the trickiest little maneuver. We need to try to get these x's together. So, can anybody think of a way that we could bring both of these x's together? I mean, do they both have an x? So, Rhett, what can we do? We can write, here's a tip for you. Can we pull an x out and multiply it to something that would take us back to that step then? Nico. Okay, does this equal what you see just above it? So rather than distributing the x, do you see how we just factored out an x from each term? Thumbs up if you understand. We pulled an x out of each. If you were to go back and distribute this, you'd end up with the original expression above it. So now we have x all in one spot. X is alone right there, okay? So what do we do to get x totally alone on the left side, Caroline?
Can we divide by x?
No, what would we divide by? We're going to leave x here. So what would we divide by? Audrey? A minus b, the whole thing. And if we divide by that on the left, then we must divide by that on the right, the whole thing. We really technically don't need parentheses because it is the only thing down there, right? But a minus b over a minus b equals 1. It equals 1. And so x equals c over a minus b. So you're using a reverse of the distributive property to get the x isolated. Now we have substituted values that we found for the variable into this transformed literal equation and found the solution of 4. So let's rewrite an equation in 2 variables. When you are asked to write an equation so that y is a function of x, what variable is being isolated? Are we isolating y or are we isolating x?
Y.
Y is a function of x. Ethan?
Y.
Why do you say that?
Because in a function, the rule would be y equals, and
Okay.
then x would be in the whole
Good.
equation.
And so y is dependent on what you do to x, is what this is saying. Y is the dependent variable. It depends on what x value you put in, or what independent value you put in. So when you're asked to write the equation so that y is a function of x, you do isolate the y. Okay, so let's isolate the y in this equation. Okay, so these are the steps that were taken here to isolate y. And you can see we now have function form. Function form means you have what variable isolated? Usually it's y. Okay, usually it means y. Okay, so solving the literal equation for x means, what do you think, Alex?
Isolating x.
Isolating x, good. So whatever you're being asked to do, solve for means you're asked to isolate for that. Here are a couple of samples to try and come back if you are watching this by video. Okay, so we isolated R and we isolated F. Our first step was not to distribute here, but was to multiply both sides of this equation by the reciprocal, which made it nice. We made it, and there you go, and good luck, and have fun.